Alright class, here we go again with our scenario and new things that we're going to learn about space, the last frontier. Our situation is the voyages of the USS Enterprise, the United States' first starship, are currently being planned. Its mission, to explore strange new worlds and seek out new life and new civilizations, to go where no one has gone before. The Enterprise will need a crew. They will be selected from graduates of the new Starfleet Academy under the direction of NASA. But there's been a delay. As a responsible republic, the selected officials of our country have asked us, the people, to hear our voice before undertaking this momentous endeavor. What processes and understandings must Starfleet Academy crew master? What should prospective crew members of the USS Enterprise know? How can we as brave young learners use this opportunity to share our thoughts and ideas with NASA? How can we master those standards ourselves? Let's use our 21st century skills of critical thinking, collaboration, communication, and creativity to help NASA develop the best Starfleet Academy instructional program. But first, our lesson. Why do we have seasons? What causes summer, spring, winter, and fall? Why does this picture show 4 seasons in mid-latitudes and only 2 in the other? Our objectives: 1. Know the Earth is tilted on its axis and that this tilt, by affecting the angle of sunlight, is responsible for the seasons. Understand how different angles of sunlight affect surface heating. 3. Recognize that different parts of the world experience different seasonal changes. So what do you already know? Earth is the 3rd planet from the Sun. Earth orbits, or revolves around, the Sun every 365.25 days, about a year. Earth's rotation causes day and night cycles. The side facing away is cooler and darker and experiences night. The side of Earth facing the Sun gets light and heat, daytime. The length of Earth's day is 24 hours due to its rotation and revolution around the Sun. For more information, click on that link. We'll stop here to give you an opportunity to take a look. So, why do we have seasons? It's all about the tilt, 23.5 degrees, not distance. The distance between Earth and the Sun has little impact on the seasons. It's the tilt, 23.5 degrees. Every day the Earth spins, rotates, once on its axis. What's an axis? An imaginary line through the center of Earth that connects the North Pole to the South Pole. Thanks to a few collisions during its formation, the Earth's axis is tilted at an angle of 23.5 degrees. What's that number again? That's right, 23.5 degrees. Only a few parts of the world experience the classic 4 seasons that we do here in Virginia: spring, summer, autumn, and winter. Many parts of the world get only 2 or even 1. So what's going on? Here we see a picture of the Earth revolving around the Sun as it rotates on its axis. As Earth takes its annual trip around the Sun, different areas of the planet face the Sun more directly during their daylight hours at different times of the year. What does that mean? What does that look like? Here we have our visual again. Visualize it. Visualize it. Got it? Good. Now add our moon. There's our moon. But that's for another lesson. Let's focus on Earth and the Sun. Back to our seasons. Where do we live? That's right, the South Atlantic. In the United States, North America. And what hemisphere is North America? That's right, the Northern Hemisphere. Good job. Where's Australia? That's right, the southern hemisphere. During summer in the northern hemisphere, where we are, Earth's north pole leans toward the sun, while the south pole leans away. When it's winter in the northern hemisphere, the south pole leans toward the sun, and the north pole leans away from the sun. So what does that mean? Well, on June 21st, our summer solstice in the northern hemisphere, the north pole is in constant sunlight, while the south pole is veiled in 24 hours of darkness. Can you imagine 24 hours of no sunlight? December 21st, our winter solstice in the northern hemisphere. Now the north pole is in darkness for 24 hours and the south pole is illuminated. The sun is low in the sky for the residents of the northern hemisphere. We have shorter days. Did you guys ever notice? Doesn't it get dark around 4 o'clock? It did in California. Got it? One more time. When our northern hemisphere is tilted towards the sun on June 21st, it's our longest day. It's summer. When our northern hemisphere is tilted away from the sun, it's winter. Those are our shortest days. What about Australia? The land down under. Down under what? Down under the equator. Where's Australia again? That's right, the southern hemisphere. What's going on in Australia, the southern hemisphere, during our summer? Our longest day matches Australia's winter solstice, June 22nd, their shortest day. That's us, and that's them, somewhere down there. Us, them. What's going on in Australia, the southern hemisphere, during our winter? Our winter solstice is Australia's summer solstice. December 22nd, their longest day of the year. More hours are spent facing the sun. They're hot. There they are. Don't worry, spin will get to them and they'll get their sun. Remember, this is December 21st. They've got another day before they get all that sun. Our shortest day of the year, December 22nd, fewer daylight hours, light spreads over a greater surface area, and we're cold. So while we're celebrating Christmas in the cold and snow, they're at the beach. Celebrating Christmas, of course. Got it? Do you have a visual? We'll do the hands-on activities in class, but for now, visualize. Visualize the Earth rotating on its axis, revolving around the sun. Then, during the summer solstice, our summer solstice, their winter solstice. Us and them. (23.5 degrees). There we are. Do you see Australia? Down there. Us and them. What about autumn and spring? In spring and autumn, the planet isn't tilted towards or away from the sun. We see that here. Spring, the spring equinox, the vernal equinox, March 21st or 22nd. The incoming solar energy equals in both hemispheres. In fall and autumn, the equinox is around September 22nd to the 23rd. And the energy from the sun equals again in both hemispheres. What does that mean? On an equinox, night and day are equal lengths everywhere on the planet, 12 hours and 12 hours. But spring and autumn only happen in mid-latitude areas of our planet. It's a different story in the tropics and at the frozen ends of the planet. Tropics. Some parts of the tropics are so constantly hot they could pass for having only one season. North Pole. Some parts of the polar regions are so constantly cold they could pass for having only one season as well. Even the sunniest Antarctic day is as cold as winter in most places. This is because the light reaching the bottom of the planet is at such a low angle it doesn't carry much heat. Antarctica. It doesn't matter if they tilted toward or away from the sun, the tropics get plenty of direct light and heat. Where are they on the planet? That's right, in direct sunlight. The tropics are constantly hot. So in the polar regions, the main difference is the amount of daylight. And in the tropics, the difference in seasons is due to rainfall. They always have sun. Daytime at the poles lasts for half the year, and the polar nights last almost as long. Those are very long, dark winters. In both the poles and the tropics, they have two distinct seasons. In the tropics, wet and dry. In the Arctic and Antarctica, polar day and polar night. Quiz time! Click on the link and take the quiz.